Okay, this is our question prep for question 4, where there's only 3 parts, A, B and C, and we're going to go through this step by step with you to show you how you go about answering these questions and show you what the correct answer is. So, start off with, we need to take a look at this graph. The graph shows how the current through the filament bulb changes after the bulb is switched on. So, if we can have a look at the current there, and we've got time in seconds here. Okay, and then we can see clearly that this here is current, that's the I, and this is time in t. If we were thinking about later on, that might become important. So the graph shows the current through a filament bulb. Now, the question says, what happens to the current through the bulb in the first 0.02 seconds after the bulb is switched on? So we're going to take a look here and find out where 0.02 seconds is, and that part is there. So 0.02 seconds here. So 0.202 seconds appears to take us up around this point over here. So what happens to the current in that section? Well, we can simply just say it increases. Okay, for the 1 mark, that is enough to get that mark. That's part A. Part B says between 0.2 seconds and 0.08 seconds, the current through the bulb decreases. And if we go and have a look at that, we can see that's the 0.8 here, and we can see it does in fact decrease. It decreases along that section there. Okay, so what, if anything, happens to the resistance of the bulb between 0.2 seconds and 0.08 seconds? Draw a ring around the correct answer. So what happens to the resistance? So if we go back to our graph and think about what's going on when we've got V equals IR. We've got V equals IR. V equals I times by R. Okay. Now, if we've got the voltage, now the voltage in the bulb is going to be 230 volts. We're going to say that that is constant. Okay, so if that is constant, and what's happening is I is going down. If I is going down, then what must be happening on the other side of things is R must be going up. Okay, so if V is going to stay the same, okay, we must say that therefore that shows an increases. It increases. Now, so when we again remind us of V equals I times by R in that first question, where V is constant and that's the 230 volts, that's mains electricity, that stays constant, okay, and we saw on the graph that that went down and then the R went up. So what, if anything, happens to the temperature of the bulb between 0.2 seconds and 0.08 seconds? Now, previously we had to think about our understanding of what causes resistance to change. And then what does cause resistance to change? Okay, so an increased resistance can be caused by a temperature increase. Okay, by a temperature increase. So this simply also increases. So that's part B done. Now, the third part, part C, the bulb is connected to a 12 volt power supply. Okay, well that's, in this case, it's not the 230 main supply, it's a 12 volt power supply. Calculate the power of the bulb when the current is 1.5 amps. Choose the unit below. Now, if we're trying to work out the power is always measured in watts. So we're going to circle watts, and the unit for that is W. So we're going to put that in there first. And then we have to remember our equation of power. Okay, power equals I times by V. P equals I V. Okay, So I, in this case, we've got here as 1.5 amps equals 1.5 amps. Okay, and V equals 12 volts. So P equals 12 times by 1.5. So 1 lot of 12 is 12, half of 12 is 6, 12 plus 6 is 18. And that is the answers to that part of the question. Okay.